Hello and welcome to this new tutorial dedicated to the power analysis mode of the DAS60. This tutorial is also suitable for the other products of the DAS30 and DAS50 range. Let's see together the different menus of this mode. First of all, let's connect the measuring leads and the current clamps to the installation to be analyzed. Now, let's move on to the instrument. First, access the Power Analysis mode by pressing Power Analysis from the home page of your instrument. The Power Analysis mode allows to analyze single-phase or three-phase networks. The different parameters are single-phase, star, delta without neutral, and delta iron, which assumes that your network is already balanced. For each selected mode, a wiring diagram is provided according to the channels to be used. You can also reset the configuration. You can customize the color of the voltage, current and frequency curves, as well as the background and grid color. In the case of an installation without a transformer, choose the direct voltage mode and then set the nominal voltage corresponding to the voltage of your installation. In the case of an installation with a voltage transformer, select a transformer voltage and set the transformation ratio parameters. Let's take the example of a power analysis with a high voltage low voltage transformer from 5500 volts to 100 volts. The nominal voltage corresponds to the range to be defined according to the primary voltage. This value should be as close as possible to the value of your voltage, but still be higher. In our case, the closest adjustable range is 6 kV for 5.5 kV of primary voltage. Next, configure the ratio. It corresponds to the setting of your transformation ratio. Set your coefficient on the left and choose whether or not to apply a factor of 10 on the right. In our example, we apply a coefficient of 55 on the primary voltage of 5.5 kV to have 100 volts at the secondary voltage. You can choose to measure the current directly with clamps or shunts. In the case of a shunt, don't forget to enter its value. If you want to use a clamp, enter its transformation ratio properly in primary/secondary. Enter the nominal current, which corresponds to the range of the measured current. In our example, we analyzed the power of a production room. The measured voltage is 230 volts between phase and neutral on the three-phase with neutral network. So, we select star in the type of circuit. We set the voltage parameters to direct voltage and the nominal voltage to 250 volts. The current to be measured is less than 250 amps. We enter a transformation ratio of 1 kA for 1 volt. The nominal current is set to 250 amps. The Fresnel diagram is shown on the left with the corresponding numerical values of your network. The state of your logic channels is shown at the bottom left of your screen. Switch to the real-time display mode by pressing the network icon at the top of the screen. You can set up your display by pressing the setup icon at the top of your screen. Display of numerical values, display of Fresnel diagram, display of voltage and current signals, display of voltage and current harmonics, setting of background, grid and cursor color. In our case, U1, U2, U3 and I1, I2, I3, the Fresnel diagram in power factor and the harmonics are selected. By clicking on the measurement on the left of the screen, access the setting of the measured values. You can choose the physical value, the type, and the range. You can also enable or disable the display of this value. For example, you can display an RMS voltage, an active, reactive, or apparent power, the harmonics, the calculation of energy in megawatts per hour, the power factor, etc. Finally, you can define your recording parameters in the Trigger menu, accessible from the main menu by pressing Trigger. For more detail about this function, watch our dedicated video, How to set up a trigger. If you want to perform a power analysis on several networks simultaneously, you can use our DAS60 which allows to analyze 4 networks at the same time. This tutorial is now over. Don't hesitate to check our other videos for more explanation. Thanks for watching.